from ray optics, where an spherical lens is given, where first spherical lens is a convex lens, biconvex lens, another is biconcave lens. Okay, so first of all, I want to make you understand the concept of a spherical lens. So what are spherical lenses? Okay, so a spherical lens, a spherical lens is a refractive medium bounded by two spherical surfaces. Refractive medium bounded by two spherical surfaces, right? Refractive medium, mind this word. Refractive medium means it can be air, glass, oil, any liquid with some density, whatever. So you can see two spherical surfaces. So if we are taking one circle, let's say like this. This is a spherical. This is a sphere. Let's say this is made up of glass, right? And there is another sphere. You can see this is a sphere 1 and this is a sphere 2, right? Then you can see the portion of both the spheres which are colliding, they are forming, and you just reduce all the figures above this. Then you can see this is the portion which is available to you, which is bulging outside both the sides. So this is called biconvex lens. Biconvex lens, right? Now this is biconvex lens, and when it can be a biconcave, plano-convex, or concavo-convex, whatever, right? And if the surface is like this, if you have seen this lens, a biconcave lens, right? It is seen like this, right? This is biconcave lens. You can see this is also a part of a sphere, right? And this is also a part of the sphere, right? So you take this section of this, and this is reflecting surface, and this is the incidence, surface of incidence, and this is the surface of emergence. Okay, so as per the definition, you can see refractive medium bounded by two spherical surfaces. So this is the refractive medium, which is made up of, let's say, glass. Okay, this is glass, and here it's, if you remove all this thing, here it's air and here it's air, right? So this medium, this medium is of glass and bounded by the two different refractive index area, right? So this is a biconvex lens, because this is bulging outside, and this will be the incidence, and this will be the emergence area, and this is the surface area 1, this one, which you can see the curve of left, right? And the area which is in the right side, this is the second area, right? So this is the area 2, right? Similarly, we can say that the refraction through a spherical lens can be considered as two successive refractions. Successive. Why? Because from air, here it's air, then you are going to glass, and from glass again you are exiting. So this is again air, right? So you can say one refraction happens over here and one refraction happens over here, right? So two refractions. This is refraction number one, and the second one, this is refraction number two. This is refraction number two, right? So two refractions are happening, right, here. And you can see that when the two successive refractions are happening, one at the first surface and another at the second surface, okay. So two successive refractions are happening in any spherical lens, right? Now just quickly coming to the numerical which we are going to solve, right? And these spherical lenses follow a formula, okay. What's that? That is 1 by f, 1 by f, that is 1 by f is equal to 1 by u plus 1 by v, we are knowing it, and 1 by f, this is also equal to mu minus 1. So this is the relative refractive index, right? So this is refractive index of medium 2 with respect to medium 1, right? We are writing it like this. This minus 1 by R1 minus 1 by R2, right? So this formula will be followed for any spherical lens. This will be followed for any spherical lens, right? So here if it's a biconvex lens, it's like this. It's a biconvex. So you can see if this is a part of a circle, right? Then if this is surface 1 and this is the incidence, then this is surface 2, this is the emergence, right? Then surface 1 and surface 2 have some radius of curvature. So the radius of curvature of first part, this one, this surface R1, you can see if it's a number line, you can see the closure of this circle, the radius of this first surface, if you consider the first surface as a part of any circle, right? And if this is going towards positive x, then we know that for a biconvex lens, R1 radius of curvature is always positive, and radius of curvature R1 for the first surface R1 is always positive for a biconvex lens, because you can see this is going towards plus x, right? If this is the number line, you can simple see, right? And you can see this is the second surface, this is having radius of curvature from in the left hand side. So in the number line, whatever going into the left hand side, only the negative, okay, it's going towards the negative x. So R2 is considered as negative, R1 is positive and R2 is negative, right? It's happening for the biconvex lens, any biconvex lens, right? Now if you consider a this one, the second one, that is biconcave lens, this one, this is biconcave. It's also called dual concave, right? So for a biconcave, you can see if this is a circle which is forming, then the radius of curvature for this one, because this is the surface 1 and this is surface 2, right? And the radius of curvature of the second surface will be lying over here. So you can easily say this is going towards plus x and this is going towards minus x, right? So for any biconcave lens, R1 is always negative and R2 is, you can say, definitely it's positive, right? Positive. So this you need to remember for a biconvex lens, R1 positive, R2 negative by using the naming convention as you followed, and for a biconcave, R1 is negative and R2 is positive, right? Now coming to the numerical which we have selected to solve, right? And all of these spherical lenses which follow the formula, right? The question was that find the focal length of the following lenses. The first lens is given to you a biconvex lens. So you need to find the focal length. F equal to what? That is focal length. So we will use the above formula, this one, right? We need to find the focal length of the following lenses which in case have mu equal to 1.6. So the refractive index mu is given as 1.6. That is for this refracting surface, that is glass. The mu is given as 1.6, right? And having radius of curvature of 10 centimeter and 15 centimeter. So if it's a biconvex lens, the data is given into the question. For the first part, the lens is biconvex and R1, radius of curvature of the first surface, this one, R1 is given to you as 10 centimeter, right? And R2 is given to you as 15 centimeter. So what will be the sign of R1 and what will be the sign of R2? R1 will always be positive, so this is fine, and R2 is 15 centimeter, but for any biconvex lens the R2 is negative, so that's why the value of this R2 will be negative, right? Now to find the focal length of this biconvex lens, we use the formula 1 by f is equal to mu 1 to minus 1. That means refractive index of medium with respect to medium 1 minus 1 by 1 by R1 minus 1 by R2. This is the formula which we will be using, right? Now here 1 by f can be written as mu. The value of mu is given to you as 1.6. So it is 1.6 minus 1 by R1. So what is the value of 1 by R1? It's 1 by 10. 1 by 10 minus 1 by R2. That is minus 1 by R2. But R2 is negative. R2 is minus 15. So it will be coming as plus. And 1 by 15. Minus sign of this 15 goes and multiplied with this minus to become positive, right? So this will give you 1 by f as 0.6, 1.6 minus 1, 0.6 into 15 plus 10 by 150, right? So this will give you 15 plus 10, 25. 25 will divide 150 in 6 times. So this will be 6 and 6 will cut 0.6 in 0.1 time. So we can say 1 by f equal to 0.1 or 1 by 10. So this will give you the focal length of the biconvex lens as 10 centimeters. So the first part of the question is solved, right? Now if it's a biconcave lens or a dual concave, double concave, and the value of R1 is given to you as 12 centimeter and R2 as 18 centimeter. then you can see for a biconcave R1 is negative. So the value of this R1 will be, what we will take is minus 12 centimeter, right? And R2 is always positive, so R2 will be used as it is, right? Now we use this formula to calculate the focal length. 1 by f equal to mu to 1. The value of this mu to 1, the refractive index of the medium 2 with respect to medium 1, right? Minus 1 by R1 minus 1 by R2, right? This will give you 1 by f equal to, the value of mu is 1.6 for both the cases as given into the question. So it's 1.6 minus 1 and 1 by R1. So R1 is minus 12. R1 is minus 12. So it will be minus 1 by 12. Taking minus in the numerator. Minus 1 by R2. So the value of minus will be this minus from the formula, and 1 by R2. R2 is always positive. So it's 18. So this will give you the value of 1 by f here as 1.6 minus 1, that is 0.6 into minus will be there, and 18 plus 12 by 18 into 12. So this will give you 1 by f equal to minus 6 by 10 into 30 by 18 into 12. So 6 3 times 18, 3 10 times 30, and 10 will be cancelled. So this will give you 1 by f equal to minus 1 by 12, right? So this will give you the value of focal length of this biconcave lens as minus 12 centimeter. You know why minus is there for a biconcave? That means it's having a virtual focus. It's having a virtual focus. Virtual focus is reflected by what? This minus sign, right? And for a biconvex lens, the focus, you can see it's plus, right? So we can say it's having a real focus. Real focus is for the biconvex lens, and for the biconcave it's a virtual focus, right? So in this way we have seen that for any spherical lens which is having a spherical lens, what we have seen, a spherical lens is a refractive medium. This is a refractive medium bounded by two spherical surfaces, and it's a reflective medium, right? So you can see here it's air, then glass, then air. So two times reflections is happening. Okay, you can see refraction 1, refraction 2. When air to glass, then again light emerging from glass to air. So two times refraction is happening, right? So that's why we understood how to solve such questions, students. So I think you liked today's session. So just like and subscribe if you find it useful. Okay, thank you so much. Bye bye, take care. I hope you liked today's session. Okay, so actually for any spherical lenses, okay, as I have explained to you, these are the basic concepts. Any spherical lens is formed by two spherical surfaces. Okay, if you consider this portion, these two arcs of these two circles, and how the radius of curvature is calculated, okay, and if we consider this arc, this side, when you considering the outer side and the inner side of this, when you consider the inner side, then you can see it's a biconcave lens. Biconcave lens is formed, right? And it's biconvex lens when it's the bulging part is considered the outer side from outside, this one. And we consider the for the same arc, if we consider the inner portion, it forms a biconcave lens, right? So in this way we have solved this question, students. Thank you so much. Bye bye. Take care.